Okay, hey guys, today we're going to talk about merge sort. As we all know, merge sort is an algorithm that is based on the divide and conquer approach. In merge sort, the main thing that we have to do, suppose we take an array, the main thing that we have to do is divide the array into subarrays, and we keep on dividing the array into subarrays until we get an one element, because one element will be sorted in itself. Then we merge all of the single array elements into one giant array, and this will give us the sorted array. So let me give you an example. So let's take an example. This is an array, this is an unsorted array. We have first have to find the middle element. So in this middle element would be 0 1 2 3 4 5 6 7, would be 3 0 1 2 3. This will be our mid, and in this mid will in the basis of this mid will divide our array into two arrays, left and right subarray, and this division will start from here. Now this will be another array, this will be another array, this will be our left subarray, this will be our right subarray. Okay, so when we go on to our left subarray, and then we go on to our right subarray, we keep on dividing both the left and the right subarrays until we get a single element in both sides, single array element on both sides in the left and the right subarrays. So when we get these elements, single elements, we'll merge them both on the left and the right hand side. So when we merge them, these elements will be sorted, merged elements, and same for this side too. Then when all of these operations are performed, we'll perform again a merge. We use a merge function to merge both the left and the right subarrays, and after that we'll get our sorted resultant array. So in this we'll be having our resultant sorted array. So now let's go to the code walkthrough. In this I have created a function merge and a function sort. Now the sort function is the driving function here. This will take array beginning and an end. So this will operate on a condition until we have traversed the full array, that is beginning is less than end. So first we have to find the mid. We'll find mid beginning plus end divided by 2. Then we call the sort function 2 times. So we can ask why 2 times, because for the first time we'll divide it into left subarray, and the second time we'll divide into right subarray. This is for the left subarray starting from beginning till mid. For the right subarray it will start from mid plus 1 and goes until end. So after the division, until we get to the last element, this division will take place, and then we'll call the merge function will take its place. Now we go on to the merge function, and I'll see this will take the same variables array start end, but there is another extra variable called mid. So in the merge function we know we have to merge the left and right subarrays and also sort them. So to do this we'll take a temporary array, initialize it from end minus start and one larger than the original array, and we'll take some indexes. Initialize the first index from start, this will handle our left subarray. Second index from mid plus 1, this will handle our right subarray, and a k variable, this will handle our temporary array. So after all of this has been done, we'll start traversing our left and the right subarray. To do this, we'll start with the while loop. Start from I, and I will traverse the left subarray until it reaches the mid, which will be the end of the left subarray, and same for the right subarray. Start from mid plus 1, go until end. So until we are in this condition, we'll compare both the elements of the left subarray and the right subarray. Suppose And after this big division, we have elements on the left hand side are 14, 7, 3, 12, and on the right 9, 11, 6, 12. Now we have a left and the right subarray, and according to the condition, if there is an element that is smaller in any of the unsorted subarrays, store that into a temporary array. So let's take this will be a temporary array. Okay, so we compare elements of both subarrays and search for the smallest element in between them. Suppose when comparing with the first, we found that the right subarray has a smaller element. So for this condition, there is else. If the right subarray contains the smaller element, we store that into a temporary variable. If left subarray contains the smaller element, we will store that into the temporary variable. And this goes on. Compare both of them, store them into the temporary variable. And when we compare both the next element, then the next element, and the next element. So after doing this, we'll get this arrangement in our temporary array. We first have 3, then we have 6, then we have 7, then 11. So there can exist a condition where, let me just write it down first, 12. So there can exist a condition where in any of the subarrays that we have at hand, there can exist a condition where there is one element left in the subarray, and the next subarray that which we are comparing it to has all of the has traversed the array fully. So in this condition, to counter this condition, we'll use this edge case where this can happen with either the left hand subarray or the right subarray. So to counter this condition, we'll start our I and go until that element or the elements that are left and store them into a temporary variable, because the left elements that are left after the execution of this condition will be larger elements, so they will be stored at the last places, maintaining the sorting order. Same goes for the right subarray, incrementing the counter if there are 1 or 2 more. So after all of this is done, our temporary array now contains the sorted elements, but we want our sorted elements to be in the original array. So we'll store all of the temporary array into our original array. To do this, we start our initializer I from start, go until the end of the temporary array and increment the I counter so that our element will be stored in each place of our original array. So after doing this, our temporary array will be copied to our original array. So let's take an example. So let me just run this code. So as you can see, this is the unsorted elements and this is the sorted array. So now guys, I walked you through the code. Now it's time to solve a problem with function. So as I have said, we first take a temporary array, temp equal to new int and minus start index plus 1. Now after the temporary array, we initialize the counters. First will be our counter for the left subarray. It will initialize from the start. Then the counter for our right subarray, start from mid plus 1. Then the counter for our temporary array for current purposes. Now we have traversed the array. We will traverse this whole array, and at this point of time it is unsorted. Then use the while loop, traverse the left subarray until it's less than equal to mid, and right subarray will start from mid plus 1, go until end. Now our condition is running. So in this, now our division has been taken place. Now we will compare all of the elements in our array and search for the least element. Suppose after the division, after the big division and all of the division that is taking place, we get one element, and at this point of time we have all of these elements in the sorted order and all of these elements in the sorted order after when each of the elements have been merged. Okay, so now it's time to compare the sorted left and the right subarray elements. So the elements in the left and right subarray are sorted when we are at this condition, because we have called this sort function 2 times. So when we call this sort function and this will return to the condition to the merge function, and in the merge function, when we completed the function, we will have sorted array. So this will be the sorted subarrays, and when we call the sort function 2 times, the left and the right side of subarray will be sorted. So we'll have to compare the elements in both of these big left and right subarrays. So suppose at first place there is 3, second place is 7, third place is 12, fourth place is 14, and first place is 6, second is 9, third is 11, and fourth is 12. We'll compare each and every element with the subarray. If we found that the left subarray contains an element which is less than the right subarray, we'll store that element into our temporary array. So we'll write this condition first. If our left subarray contains the element that is less than the right subarray, temp I is less than 10, contains elements that are less horizontal array, right? It contains left hand side are elements less than the elements in the right hand subarray. We store that element into a temporary array. Store this element and increment the count I plus plus k plus plus else store that element from the right subarray to the temporary, because if we go on with this else condition, this means the right subarray contains the least element. After the execution of this while loop, this means that we have placed the sorted elements in a temporary array, but there can exist a condition where we still have elements left in either the left or right subarray. Suppose we're comparing both the elements. First, in our temporary array, suppose in a temporary, this is our temporary array. Okay, the first element would be 3, second element would be 6, third element would be 7, because after comparison, the else condition we executed, we get 6, then we get 7, because 7 is less than 9 and they are compared. Then comes 9. When we compare 12 with 11, 11 is smaller, 11 will come first. then compare 12 with 12 because they are repeated elements. 12, again 12. Now at this point of time, well, we have exhausted our right subarray, but there is still element left in our left subarray. So what we do, so to counter this condition, we'll simply use this loop. We'll traverse until while our I is less than equals mid. We'll traverse it until it is less than mid, until there is some element left. Store that element into our temporary array I, because at this point of time I will be at these kind of elements that are left behind at the end, and also the element that would be left behind would be larger elements, because according to our this condition, all the smaller elements would have filled the places first, and the places that we're filling now would be places for the larger elements. So implement both if there are one or more elements in there, and same goes for right subarray. Just take it from J, so K++. So this is the reason, that's why we have instantiated our temporary array to +1, so that we can combat this condition. So after this condition is executed, we'll have completed our merge function, but at this point of time our temporary array has all of the sorted elements that we want, but we want the sorted elements in our original array. So what we do, we'll copy all of these elements from temporary array into our original array. So to do this, I'll use a for loop. For start from I, go till the end of the array, increment, and store the elements, sorted elements in a temporary array to our original array. With this condition, we'll copy all of the elements from our sorted temporary array to our original array. Now we'll compile. Yes, as you can see, we've successfully passed our first test case. Now we'll just submit and see whether we can pass all our test cases or not. This condition is true. We'll copy it right, and this. It is taking a long time. Oh, guys, as you can see, we got the answer correct. Execution time is somewhat more, but this is with Java. C++ is more faster. We are in the merge method. Everything is same, just we take two arrays instead of one temporary array. We're here given a method sort, merge sort, and we'll traverse it until we traverse the whole array, find the mid, and call the traverse two times as in the last time for the left and the right subarray, and then call the merge function. So now let's see what's different now in the merge function. So in the merge function the arguments are the same, but here's the catch. We'll initialize two variables, first for the left subarray size and second for the right subarray size, and minus mid minus beginning, at +1 for the edge case. And now we'll initialize two empty arrays, and we'll initialize them to the size of the left array and the right subarray. After initializing both the arrays, now we insert the elements from the original array to the left and the right subarray. To do that, we'll start from our pointer I from 0, and we'll go up till the length of the left subarray, and in this we're transferring the elements from the original array to the left subarray, and we've used beginning here because this is indicating that we've started transferring the element from the start until we reach the condition.
and it's same for the right subarray. Insert We started inserting elements to the right subarray from the original array from mid plus 1, and the j counter is to get the additional values of j. This mid plus 1 beginning just indicates from where we have started in the original array to insert the elements in the left and right subarray. Now we have inserted elements in the left and right subarray, but the elements are still unsorted. So to do that, to counter this problem, we'll initialize three more variables. First I variable, then j variable, and I and j initialized to 0, and k variable for original array, and we'll start it from beginning. Now we'll traverse the array left and right subarray until we reach its end. Now in both of the left and right subarray, this method is the same as like the last one. Compare the elements in both the left and the right subarray. The smaller elements get stored in the origin. This time, instead of the temporary array, it gets stored in the original array. I will increment the counter on the left subarray. And if the another condition is true, that is the right subarray has a smaller element than the left subarray, then we'll transfer that element to the original array and increment the counter to see whether there are more elements or not. After this condition, we'll also increment the array to get to our next place. So now when all of these conditions have been executed, just like the last time, there can be some element either in the left or the right subarray. Left, when we have fully exited this condition, because we'll exit this condition when either left or the right subarray is fully traversed. So if at some point right subarray is fully traversed, like in explained in the last example, left subarray has still some element left, so I'll store that element in the last positions of our subarray, because the first places have been already been filled up by the smaller elements. I will increment the counter because there can be more than one element. Same goes for the right subarray. Now we'll just compile and test the code whether it will run properly or not. Okay, yes, as you can see, our code sorted the elements. So guys, here you can see we've passed all of our test cases. Yes, the execution time is more, but you can neglect that for the time being. You can see that this method worked, and I have discovered it in the meantime after I have edited the video. So I leave this upon you guys to choose which method, of which of the two methods explained you want to choose. If you like this video, please give it a thumbs up and subscribe the channel. If you have any comments and suggestion, please write down in the comment section. Thank you.